Hi everyone, welcome to Infinity Learn by Sri Chaitanya. My name is Vibhati Jain and in today's session I'll discuss circular motion PYQs with you. तो जो बच्चे नीट के लिए प्रिपेयर कर रहे हैं उनके लिए ये सेशंस बहुत ही इंपॉर्टेंट हैं. इनफैक्ट सारे ही आपके जो PYQ सेशंस हैं, चाहे वो फिजिक्स हो, केमिस्ट्री हो, बायोलॉजी हो, सारे सेशंस आपके लिए इंपॉर्टेंट है बिकॉज अब नीट एग्ज़ाम में हार्डली 1 मंथ रह चुका है और इस 1 मंथ में आपको मैक्सिमम PYQs और मॉक टेस्ट करने हैं, राइट. सो ये सेशंस आपको PYQs में बहुत हेल्प करेंगे. PYQ समझने में, नीट का पेपर का जो पैटर्न होता है उस पैटर्न को समझने में बहुत ज़्यादा हेल्प करेंगे. तो फटाफट से आ जाइए, अपने फ्रेंड्स को भी बुला लीजिए बिकॉज आज हम बहुत ही इंटरेस्टिंग चैप्टर सॉल्व करने वाले हैं, दैट इज सर्कुलर मोशन. बट बिफोर दैट गाइज, यू आर ऑन इन्फिनिटी लर्न नीट, तो फटाफट से सब्सक्राइब कर लीजिए ताकि आने वाले PYQ सेशंस का आप मज़ा लेते रहें और उसके साथ आप सीखते भी रहें, समझते भी रहें कि क्वेश्चन कैसे आपको पूछा जा सकता है नीट एग्ज़ाम में, राइट. सो उससे पहले गाइज हमारे पास आपके लिए फ्री मास्टर क्लासेस हैं जिसमें आप क्या क्या कर सकते हैं. फ्री मास्टर क्लास अटेंड कर सकते हैं बाय मास्टर टीचर्स. इन्फिनिटी लर्न के जो एक्सपर्ट्स हैं, सब्जेक्ट एक्सपर्ट्स हैं, उनसे आप पढ़ सकते हैं, उनसे पढ़ने का मौका आपको इस क्लास में मिल सकता है. आप फ्री रजिस्ट्रेशन अपना कर सकते हैं. उसका लिंक जो है दैट इज़ इन डिस्क्रिप्शन बॉक्स. लिंक आपको डिस्क्रिप्शन बॉक्स में दिया गया है. बच्चे, जब आप एक फ्री मास्टर क्लास अटेंड करेंगे तो आपको एक इन्फिनिटी लर्न टेस्ट आपके लिए अनलॉक हो जाएगा. आप उसे अटेम्प्ट कर सकते हैं. साथ ही साथ आपको 2 फ्री मॉक टेस्ट मिलेंगे और 14 फ्री PYPs, प्रीवियस ईयर क्वेश्चन पेपर्स आपको मिलेंगे. तो एक क्लास के साथ आपको बहुत सारे बेनिफिट्स यहाँ पे दिए जाते हैं. आपको कुछ नहीं करना है, डिस्क्रिप्शन बॉक्स में देयर इज़ वन रजिस्ट्रेशन लिंक, जाके क्लिक करो वहाँ पे और अपने आप को रजिस्टर करो और इन सारे बेनिफिट्स का फ़ायदा उठा सकते हो. ऑल राइट, so let's start with question number 1 guys. Question number 1 was in 2019 paper and question पढ़ते हैं, समझते हैं और देखते हैं कि इसको कैसे सॉल्व किया जा सकता है, right. So question is, 2 particles A and B are moving in uniform circular in concentric circles of radii RA and RB with speed VA and VB. ठीक है, मेरे पास एक पार्टिकल है, वो ऐसे किसी रेडियस RA वाले सर्कल में मूव करता है विथ स्पीड VA और दूसरा पार्टिकल है B. सेकेंड पार्टिकल इज B एंड सेकेंड पार्टिकल आपका जो है वो कॉन्सेंट्रिक सर्कल में मूव करता है ऑफ रेडियस RB एंड विथ स्पीड VB. ये अभी तक दिया हुआ है, ओके. The time period of rotations is the same. बोला क्या, A का जो टाइम पीरियड ऑफ रोटेशन है वही B का टाइम पीरियड ऑफ रोटेशन है. The ratio of angular speed of A to that of B will be. ओके, हमसे ये पूछा गया, ये सब इंफॉर्मेशन दे के हमसे पूछा गया कि ओमेगा A इज टू ओमेगा B क्या होगा. What is the value of omega A is to omega B? क्या आप ट्राई करना चाहेंगे इस क्वेश्चन को एवरीवन? फटाफट से ट्राई दिस क्वेश्चन एंड लेट मी नो द आंसर इन द कमेंट सेक्शन ओवर हियर कि ओमेगा A इज टू ओमेगा B क्या होगा. ठीक है, इंफॉर्मेशन सारी आपके सामने है. आपसे बोला टाइम पीरियड ऑफ रिवॉल्यूशन ऑफ A इज इक्वल टू टाइम पीरियड ऑफ रिवॉल्यूशन ऑफ B. एक का रेडियस RA, एक का रेडियस RB, कॉन्सेंट्रिक सर्कल्स, एक का वेलोसिटी स्पीड आप बोल सकते हैं VA और दूसरे का स्पीड है VB. ट्राई करो एवरीवन, ट्राई दिस वन गाइस फटाफट से एंड लेट मी नो व्हाट विल बी द करेक्ट आंसर ऑफ दिस क्वेश्चन. इट वाज इन नीट 2019 पेपर. ठीक है, और इसको सॉल्व करने के लिए बस एक ही चीज़ की रिक्वायरमेंट है, दैट इज क्वेश्चन ढंग से पढ़ा हुआ होना चाहिए. अगर आपने क्वेश्चन ढंग से पढ़ के समझ लिया तो आंसर मार्क करने में हार्डली आपको 2 सेकेंड्स लगेंगे. कैसे समझते हैं, चलो आओ फटाफट से समझते हैं इस क्वेश्चन को. बोला क्या, टाइम पीरियड ऑफ रिवॉल्यूशन ऑफ A इज इक्वल टू टाइम पीरियड ऑफ रिवॉल्यूशन ऑफ B. बस कहानी यहीं पे खत्म हो जाती है इस क्वेश्चन की. RA, RB, VA, VB डजंट मैटर क्या दिया हुआ है, कितना दिया हुआ है, नहीं मतलब है। क्यों? क्योंकि अगर मैं ओमेगा ए की बात करूं तो ये हो जाएगा 2 पाई बाई टी ए, एंड ओमेगा बी की बात करूं तो ये हो जाएगा 2 पाई बाई टी बी। अब टी ए टी बी बराबर है तो 2 पाई बाई टी ए और 2 पाई बाई टी बी भी तो बराबर होंगे, ये दोनों भी तो आपस में इक्वल होंगे। अगर ये दोनों आपस में इक्वल हैं तो ये दोनों भी आपस में इक्वल होंगे, तो बेसिकली ओमेगा ए ओमेगा बी के बराबर हो जाएगा। तो ओमेगा ए अपॉन ओमेगा बी जो रेशियो आएगा दैट इज 1, राइट। लो कहानी खत्म। तो 1:1 is the correct answer which is option A. 1:1 is the correct answer which is option A, right? तो कुछ नहीं करना इसमें, सिर्फ क्वेश्चन को ढंग से पढ़ना है, राइट। चलो अगर कोई भी यस बेटा, वेल डन, ऑप्शन ए इज द करेक्ट आंसर, वेल डन बेटा, वेल डन। Next is this one. It was in NEET 2019 paper. Again, a particle starting from rest. Okay. Initial velocity of the particle is 0 and it is moving in a circular path of radius r. It attains a velocity v naught in the nth round. After completing nth round of its circular path, it attains a velocity v naught. What is the angular acceleration? Okay, what will be the angular acceleration of this particle, that is alpha? What will be the angular acceleration of this particle? Alpha क्या होगा everyone? Starting from rest, after nth revolution, its speed is v naught. What will be the value of alpha? That we need to find out, guys. Try this one फटाफट से। Try this question everyone. These are 4 options. बताओ क्या होना चाहिए? What will be the correct answer? Bardwal, what will be the correct answer? This question is directly based on the equation of motion, right? Let's try this one. Let's try this one. Chalo, try this one, guys, and try to make a proper diagram so that you can understand what is happening here. Okay, so this is circular path. When particle is starting from here at this particular point, its u is 0 and v is equals to what is the relation between v and omega? Use that relation over here, and I'll give you one more hint over here, that is we need to use this equation. Omega square is equals to omega naught square plus 2 alpha theta. ठीक है, v is equals to omega r. Use this one and this one for calculating the correct answer, guys. ठीक है, चलो। So if initial velocity is 0, then omega naught, initial angular velocity, will be vu upon r, that is equal to 0. ठीक है, after nth revolution, it is moving n rounds like this. Okay, its angular displacement theta will be 2 pi n. It is rotating 2 pi radian in 1 revolution. So in n revolutions, it will rotate 2 pi n. Well done beta, well done. ठीक है, so we have theta, we have omega naught. We need to find omega now, right? So omega is v upon r, but final velocity is v naught and r is the radius. So this is v naught upon r. ठीक है, let's put all these values in this equation. So you'll get your answer as omega square is v naught square upon r square. Omega naught square will be 0 plus 2 alpha theta. Theta is 2 pi n, right? So alpha will be v naught square upon 4 pi n r square. So this is the value of alpha, which is v naught square divided by 4 pi n r square. So correct answer is option I think C and D both are equal, right? So yeah, C. Let's mark it as C. Let's keep this one as V naught only. ठीक है, चलो, well done beta, well done. I hope this is clear. Excellent. Next is this one. In the given figure, okay, I'll tell you what is the diagram here. This is a circle and this is center and this is acceleration, which is 15 meter per second square, and this angle is 30 degree. ठीक है. So in this given figure, the total acceleration of particle in the clockwise direction is 15 meter per second square and radius is 2.5 meter. Radius of the circle is 2.5 meter. Question is, the speed of the particle is, what is the speed of this particle who is performing the circular motion, right? So try this one everyone, try this one guys. What will be the correct answer? What will be the correct answer guys? We have A 15 meter per second square and it is making an angle of 30 degree with the radius, right? And the radius is 2.5 meter. We need to find the speed of the particle at this particular instant and we have option C. Well done bachcho, well done, well done. So if I make this diagram here, this is a circle and this is the radius R and this is A, which is 30 degree. This angle is 30 degree and this is 15 meter per second square. So if you take the component of this A, there will be two components. One is along radius, which is this one, A cos 30 degree, and other one is along tangent, that is A sine 30 degree. So this is nothing but centripetal acceleration and this is nothing but what? Tangential acceleration. So centripetal acceleration is A cos 30 degree, which is equal to V square upon R, right? So over here A cos 30 degree is equal to V square upon R. So A is 15, cos 30 degrees root 3 by 2 divided by V square upon R. R is 2.5. So V square will be 15 into root 3 into 2.5 divided by 2, and if you take the square root on both the sides, you will get the value of speed and that is equal to 5.7 meter per second, right? So correct answer over here is option C, 5.7 meter per second. I hope this is clear guys. Any doubt so far? Any doubt in this questions? Okay, if you have any doubt, just let me know in the comment section over here. Chalo, next is from 2011. A particle moves in a circle of radius 5 centimeter with constant speed and time period 0.2 pi second. The acceleration of the particle is. So radius is given as 5 centimeter and it is moving with constant speed and time period t is given as 0.2 pi seconds. What is the acceleration of the particle? We need to find acceleration of the particle guys. Try this one everyone. Fatafat say. Try this one. Radius is given as 5 centimeter. You can convert it into SI unit first. So it will be 0.05 meter and it is moving with constant speed. So it is performing uniform circular motion. So acceleration of the particle will be only centripetal acceleration, which is towards the center, and it is given as omega square into r. ठीक है, omega is written as 2 pi upon t. So this is 2 pi upon t ka square into r. So this is 2 pi upon t, t is 0.2 pi का square into r is 0.05. ठीक है, let's remove this point. So this will be 10 का square, that is 100 into 0.05, right? So this will be 5 meter per second square. ठीक है, this will be 5 meter per second square. So correct answer for this one is option D, 5 meter per second square. I hope this is clear, guys. ठीक है, if you have any doubt, just let me know. Next is this one from 2019 paper, very recent one, guys. A block of mass 10 kilogram is in contact against the inner wall of a hollow cylindrical drum of radius 1 meter. So we have one hollow cylindrical drum, something like this, and one block is in contact with the inner wall of this hollow cylindrical drum and radius is 1 meter. The coefficient of friction between the block and the inner wall of the cylinder is 0.1. Coefficient of friction is 0.1, not meter, sorry, 0.1. The minimum angular velocity needed for the cylinder to keep the block stationary when the cylinder is vertical and rotating about its axis is. So this is the axis of the cylinder, and if it is rotating about its own axis with angular speed omega, then what should be the minimum value of omega so that this block remains stationary with respect to cylinder, है ना? हमें पता करना है कि ओमेगा का मिनिमम वेलोसिटी, ओमेगा का मिनिमम वैल्यू क्या होना चाहिए ताकि ये ब्लॉक जो है वो सिलेंडर के रिस्पेक्ट में क्या रहे, स्टेशनरी रहे, राइट? सो ट्राई दिस वन, दिस आर योर ऑप्शंस गाइस, ट्राई दिस वन. Very nice question everyone from 2019 paper. It has friction, it has circular motion, right? So very nice question. Try this one. What do you think? Omega should be 10 pi or under root 10 or under root 10 upon 2 pi or SIF 10. What do you think, guys? If you know the answer, you can write that answer in the chat box over here in the live chat. Try this one, guys. I'm still waiting for your response. Very nice question, very small solution, but yeah, conceptual question. Let's solve it together, guys. Let's solve it together. Let's make a proper diagram here. So this is a cylinder like this, and radius is 1 meter. This is the axis of the cylinder about which it is rotating with angular velocity omega, and this is the block which is attached on the inner wall of the cylinder. Okay? Now the question is, what should be the value of omega so that this block remains stationary with respect to cylinder? Matlab, with respect to cylinder, net force on this block should be 0, right? So let's identify all the forces over here. Not this one, this is the question. Mass is 10 kilogram, radius is 1 meter, and coefficient of friction is 0.1 and G is 10, right? So if you identify all the forces, mg is acting downwards, it has sliding tendency in the downward direction, so friction will be upwards, normal reaction will be like this, right? So basically friction should balance mg, right? So mg is mass into acceleration due to gravity, where friction is mu into n, right? So this is mu into n, and that is equal to mg. So n should be mg upon mu, and that is m is 10, g is 10, mu is 0.1, so it should be 1000 Newton. So this is the value of normal. Now normal, if you look at the path of this block with the rotation of this cylinder, this block is also performing circular motion like this. Okay? So the path of this block is something like this. It is on this circle, it is moving on this circle with cylinder with respect to us. Well done Badwal, well done beta. Okay? So this normal is towards the center and it should be m omega square into r, right? So normal is m omega square into r. So m is 10, omega square is unknown and r is 1, and that is equals to 1000. 0 0 cancel, so omega square is 100. So omega will be under root of 100, that is equals to 10 radian per second. So value of omega will be 10 radian per second. Well done beta. Yes, your answer is correct, which is option D. Well done everyone, well done guys. Alright, now let's move on to the next question. Next question is from 2017 paper. Very nice question, directly based on the definition. Okay, you don't have to solve anything in this question. One end of a string of length L is connected to a particle of mass m and the other end is connected to a small peg on smooth horizontal table. So we have smooth horizontal table, and on this table one end of the string is connected to the peg and other end is connected to the particle of mass m, right? And if particle moves in a circle with speed v, if the particle is moving in a circle with speed v like this, L is the length of the string, the net force on the particle directed towards the center will be, what is the value of net force on the particle directed towards the center, where T represents the tension in the string. Okay, T represents the tension in the string. Okay. So there are two options that might confuse you. One is this and other one is this, right? So generally what we do is, okay, this particle is connected to string, so tension will be there. On this particle, tension will act towards the center, right? But since it is in circular motion, so one centripetal force will be always there, that is mv square upon r. So what students do is they add the tension with mv square upon r and they'll mark correct answer as option A. But that is wrong. Okay, that is wrong. Why? Because mv square upon r is not a different type of force, it is the force which is responsible for the circular motion, right? The force which is acting towards the center behaves like a centripetal force. Okay? So over here, tension is the force which is acting towards the center. So tension is behaving like a centripetal force. Okay? So net force towards the center is tension only, which is option D. So if you look at this complete question, this question is based on the definition of centripetal force. That's it. Okay, you don't have to solve anything. You don't have to do any calculation. By looking at this question, if you know what is the definition of centripetal force, you can mark correct answer within 5 seconds. Okay? Chalo, excellent guys. Let's move on to the next question. This question was in 2016 first paper. Very nice question. Question is, a car is negotiating a curved road of radius r. The road is banked at an angle theta. Okay. So let's say we have a banked road and the banking angle is theta and this road is curved something like this. Okay. Car is moving on this curved road and the radius of this curved road is r. Fine. The question is, if the coefficient of friction between the tire and the road is mu s. So these are 4 tires of the car. The coefficient of friction between the tire and road is mu s. Then the maximum safe velocity on this road is, what should be the maximum safe velocity of the car so that it can take this circular turn without skidding, without sliding. Okay, so try this one guys, very nice question, conceptual question. Okay, try this one. Meanwhile hum thoda sa, I'll drink some water because we have lots of questions to do, right? Very interesting questions. So we have one answer from Bardwal, that is option D. Well done beta. In fact, you should remember maximum and minimum velocity for this case. Okay, because in NEET exam they directly ask this formula. Fine. So let's solve this question for banked road. I'll tell you what is the method, and after that you can directly remember the correct answer. Right? You don't have to derive it every time. Okay. Chalo. So this is a banked road, and the road is something like this. Okay, curved road. So this is somewhere over here is the center of the road. Okay, center of this circle, right? And this is car. So mg will act in the downward direction. Normal will be like this, perpendicular to the surface, and with that there will be one more force, that is friction. So friction will be like this, Fs. Okay. Now resolve all the forces along x-axis and y-axis. Okay, resolve all the forces along x-axis and y-axis. So if this angle is theta, this angle is also theta, and this angle is also theta, and if this is theta, then this is also theta. Okay, fine. So what do we have? We have normal like this, mg like this, and fs like this. This is not this one. Just a second. This angle is theta and this angle is theta. Okay. Let's resolve normal. So this is n cos theta and this is n sin theta. Similarly, let's resolve fs. So this will be fs cos theta and this will be fs sin theta. Okay, fine. So n cos theta is vertically upward and it will balance fs sin theta and mg, right? So basically n cos theta is equal to fs sin theta plus mg. So you can write n cos theta minus fs sin theta is equal to mg. Fs is nothing but mu s into n, right? Fs is nothing but mu s into n. So in that case it is n cos theta minus mu s into n into sin theta is equal to mg. This is equation 1. Second is these two forces n sin theta and fs cos theta. These are towards the center of the circular path. So these two are acting as centripetal forces, right? So n sin theta plus fs cos theta. You can write fs cos theta as mu s into n cos theta is equal to mv square upon r. This is equation 2. Now divide equation 2 by equation 1. So this is equation 2, let's divide it by 1. So this will be n cos theta minus mu s into n sin theta divided by mg. Cancel. You can take n common and cancel it out. So we have sin theta plus mu s cos theta divided by cos theta minus mu s sin theta is equals to v square upon rg, right? Now let's take sin theta common. So okay, so after taking sin theta common, you are left with, from numerator and denominator, sin theta will, so this is 1 plus mu s, let's take cos theta common, sorry. I want to make it tan because answer is in tan, right? So I'll just remove this entire portion. And let's take cos theta common. So this is sin theta upon cos theta plus mu s divided by, take cos theta common from the, okay, cos theta common from the denominator. So this is 1 minus mu s sin theta upon cos theta. Cos theta cancel, and that is equal to v square upon rg. Okay. Sin theta upon cos theta can be written as, sin theta upon cos theta can be written as what? It can be written as tan theta. So I am writing it here, v square upon rg is equal to tan theta plus mu s, I hope this is visible, tan theta plus mu s upon 1 minus mu s tan theta. Tan theta plus mu s upon 1 minus mu s tan theta, right? So v square will be rg into 1 mu s plus tan theta divided by 1 minus mu s tan theta. Okay? Take the square root on both the sides, guys. You will get the value of v, maximum safe velocity v, as under root rg into mu s plus tan theta divided by 1 minus mu s tan theta, which is option D, right? So directly you can remember this value. You don't have to do this derivation every time. Just remember this value. Fine. I hope this is clear. Now next is from 2015 paper. We have two stones of masses m and 2m, right? We have two stones of masses m and 2m are whirled in a horizontal circles, the heavier one in a radius of r by 2. Heavier one is 2m, so it is in the radius of r by 2, and lighter one in the radius r. The tangential speed of lighter stone is n times that of the value of heavier stone. If heavier stone is moving in a horizontal circle with tangential speed v, then lighter stone will move in this horizontal circle with tangential speed nv, right? The question is, when they experience same centripetal forces, what will be the value of n? These two masses are moving in the horizontal circles with different radius, different tangential speeds, लेकिन they are experiencing same centripetal force. Then what is the value of n? इसके लिए value of n क्या होना चाहिए, है ना? What will be the value of n? Try this one, guys. Try this one. What will be the value of n? Everyone, try this one. Centripetal force is same, which is mv square upon r. Equate mv square upon r. ठीक है, well done, well done, well done. Bardwal, well done, beta. Let's discuss this question now. For the first particle, lighter particle, it is m into nv ka whole square divided by r, and this centripetal force is equal to centripetal force of the heavier particle, which is 2m into v square upon r by 2, right? So this is 2m into v square upon r by 2. So this is m n square v square upon r, and that is equal to 4m v square upon r. So cancel m v square r r, so we have n square as 4. n square as 4, तो n क्या हो जाएगा? n is under root of 4 and that is 2. ठीक है, तो n का वैल्यू आ गया 2, which is option C. Well done beta. I hope this is clear, राइट चलो आगे बढ़ते हैं. लेट्स मूव ऑन टू द नेक्स्ट क्वेश्चन. It was in Karnataka NEET 2013 paper. Question is, a car is moving in a circular horizontal track of radius 10 meter with a constant speed 10 meter per second. Okay. A bob is suspended from the roof of the car by a light wire of length 1 meter. The angle made by the wire with the vertical is, wire of the pendulum will make some angle theta with the vertical. आपको बताना है what is the angle made by the wire with the vertical. ठीक है, try this one guys, try this one. In fact you can also remember the expression, है ना, इसका जो expression आएगा वो आप याद रख सकते हो बच्चे. क्या होगा? Which option is correct? Option 4, Raghavendra. Okay, Raghavendra is saying option 4, 0 degree. You don't have to delete it beta. Just be confident कि ठीक है, जो होगा देखा जाएगा. Option 3, okay, that is pi by 4. All right guys. What do you think, Bardwal? What do you think, beta? What's your answer? What's your answer, guys? Let's discuss this question now. The car is moving in a circular horizontal track of radius 1. Car is like this and the radius is 10 meter. There is one pendulum inside it and it will make certain angle theta with the vertical. We need to find the value of angle theta with the vertical. Okay, fine. So let's assume that this is the ceiling of the car and pendulum is inclined at an angle theta with the vertical. So let's find all the forces. Let's find all the forces that are acting on the pendulum. So this is mg. This will be tension. If this angle is theta, this is theta. Let's take the component. So this is t cos theta and this is t sin theta, right? So basically t cos theta is like this, t sin theta is for this pendulum, t cos theta is like this, mg is like this and t sin theta is acting towards the center of the circle. Okay? So over here t sin theta is nothing but the centripetal force for this pendulum, right? So t sin theta is mv square upon r and t cos theta is mg, right? Divided guys, tt cancel, cancel, sin theta upon cos theta is tan theta and that is equals to v square upon rg. If you want, you can remember this value. Tan theta is v square upon rg, right? So over here, let's put the value of v, r and g to find the value of theta. So it is v square, 10 into 10 divided by r is 10 and g is 10. So this is equal to 1, right? So tan theta is 1 when theta is 45 degree or pi by 4, right? When theta is 45 degree or pi by 4 radian. I hope this is clear. Now, Bardwal, okay. So this is the correct answer, which is option C. Chalo. Let's move on to the next question. This was in 2012 paper. A car of mass 1000 kilogram negotiates a banked curve of radius 90 meter on a frictionless road. Okay. If the banking angle is 45 degree, the speed of the car is. So we have a banked road of angle theta and car is moving on this with a certain velocity, let's say v. We need to find the value of V if theta is 45 degree and radius is 90 meter and the mass of this car is 1000 kilogram. Mass of this car is 1000 kilogram. Try this one guys, try this one. We have option B from Bardwal, that is 30 meter per second. Well done. Again you can directly remember the expression, right? Because this is nothing but formula based question. If you know the formula, you can answer this question easily. Okay. Chalo, Raghavendra, what do you think? Let's solve this question. Okay, so this is banked road. This is theta. This is car. Let's find all the forces. So this is mg, normal, and if this is theta, then this is also theta, this is also theta. Let's take the components of the normal. Okay, components of the normal, right? So this component is n cos theta and this component is n sin theta, right? So n cos theta is balanced by mg and n sin theta is behaving like a centripetal force for this car, right? So this will be n sin theta is equal to mv square upon r and n cos theta is equal to mg. Divide it, n cancel, sin theta upon cos theta is tan theta and that is equal to cancel, v square upon rg. So v square is rg tan theta, or you can write v as under root rg tan theta. Okay, so you can directly remember this value बच्चे, you can directly remember this value. Well done Bardwal and Raghavendra, बहुत ही बढ़िया guys. Let's put the value of rg and tan theta in this case. So v is under root rg tan theta, so it is under root r is 90, g is 10 and tan 45 degree is 1. So this is under root 900 which is 30 meter per second. So correct answer is option B. ठीक है? Yes, excellent. Correct answer is option B. Well done guys. Now let's try this one. Sorry. If a car of mass m is moving on a level circular track of radius r, mu s represents the static friction between the road and the tire of the car. The maximum speed of the car in circular motion is given by. Again, if you know, you know, right? Again, this question is formula based. It was in mains 2012. Try this one guys, try this one. Chalo guys, फटाफट से. Option D from Raghavendra and Bardwal. Well done bachcho. So this is circular track and on the circular track one car is moving. Okay, so normal and mg, normal will be ऐसे and mg will be downward. Like if you look at the top view of the car, mg will be something like this and normal will be something like this and friction will be something like this. ठीक है? So normal is balanced by mg and friction, which is mu s into n, is equal to mv square upon r. But n is mg, so mu s into mg is equal to mv square upon r. Cancel. So mu s into g into r is v square. Take the square root. You will get the value of v as under root mu s g r. ठीक है? So yeah, the value of v as under root mu s r g, which is option D. And yes, you guys were correct. Well done guys, well done. Next is this one, 2016 paper. What is the minimum velocity with which a body of mass m must enter a vertical loop of radius r so that it can complete the loop? We did a derivation of this particular question in the previous session, that is in previous session, PYQs or work power energy. You can go and watch that session. I've derived everything in that particular session for this question. Okay, tell me guys, what will be the minimum velocity at the lowest point of the body so that body can complete this vertical circle? Option B from Raghavendra, well done. Option B from Raghavendra, well done. Option B from Raghavendra. Bardwal, what do you think, beta? Option B from Bardwal, yes, beta. Minimum velocity at the lowest point is under root phi gr and at the highest point it is under root gr for completing this loop. So correct answer is option B. Well done, guys. It was in 2016 first paper. You can look at these questions, guys. These questions are directly formula based, right? So this chapter is very small and very easy chapter. If you know all the formulas, there is no difficult question for you guys in this chapter, right? So make sure you know each and every formula so that you can solve these questions within 5 seconds. Okay, chalo. Next is this one from 2003, quite old, but personally I like this question a lot. That is why I've included this question over here. This question will teach you something. You will learn something new in this question. So let's understand this question first. Question is, a stone is tied to a string of length L. Okay. Stone is tied to a string of length L and it is walled in a vertical circle like this. Okay. With the other end of the string as the center of the circle. Okay. At a certain instant of time, the stone is at its lowest position and has speed u. When the stone is at lowest position, it has speed u. The magnitude of the change in velocity as it reaches a position where the string is horizontal. When the string is horizontal, let's say its speed is v, we need to find what is the change in velocity between this position and this position of the stone. Try this one, guys. Just think about it, how to solve this question. Then we'll discuss this question together, right? So try this one. We need to find the change in velocity, right? So this velocity is nothing but a vector quantity. So this completely changes, this fact completely changes the method for solving this question, right? If you want to find change in speed, that's okay. But if you want to find change in velocity, we have to consider direction also. Direction is also important, right? You can see that direction is also changing with the change in position of the particle. Okay. So let's solve it, guys. This is circle, vertical circle. At the lowest position, it is u, and at the horizontal position, it is v. Okay. I'm considering this as my positive x-axis and this direction as positive y-axis. So basically this initial velocity is ui cap and final velocity is vj cap. Okay. So change in velocity delta v vector is vj cap minus ui cap. Fine. Now let's find the magnitude of v. So for that I'll be needing conservation of mechanical energy. Okay. So I'm considering this level as my reference level. Okay. So in that case, over here the energy, total mechanical energy of this particle is half mu square plus u initial potential energy of the particle. At this point, its height is increasing by L. So it will gain some potential energy. So new potential energy will be ui plus mgl plus kinetic energy will be half mv square. And there is no friction in this motion, right? So you can conserve mechanical energy. Matlab mechanical energy at this position is equal to mechanical energy at this position. So this mechanical energy is equal to this mechanical energy, ui cancel. So half m v square is equal to half m u square minus mgl. M cancel. So v square is equals to u square minus 2gl. So v is under root of u square minus 2gl. This is the magnitude of v. This is the magnitude of v. So it is under root of u square minus 2gl j cap minus ui cap. Okay. Now I want to find the magnitude of delta v. Okay. So I'll just write it here. Let me find some space by removing this one. So we have delta v as under root of, what is the answer? Under root of u square minus 2gl j cap minus ui cap. So delta v vector magnitude is under root of coefficient of j ka square plus coefficient of I ka square. So this is under root of u square minus 2gl ka whole square plus minus u ka square. Okay? That is how we find the magnitude. So this will be under root of u square minus 2gl plus u square, and this is under root of 2u square minus 2gl. You can take 2 common. So this will be 2 times under root of 2 times u square minus gl. So this is the change in velocity, which is option A. Change in velocity of the particle between lowest and the horizontal position, which is option A. I hope this is clear, guys. Any doubt in this one? Birdwal and Raghvendra Bita? Any doubt so far? If you have any doubt, just let me know here. Fine. So I think this is the last question, guys, and we have one more exciting offer for you. We have NEET 2022 Rank Assurance Ultimate Package for you. Okay, this is Rank Assurance Ultimate Package, in which we have live classes. Okay, we have live classes for you in Rank Assurance program. We have self-learn videos. By watching these videos, you can learn new things, right, without help of your teacher. If you have any doubt in anything and if teacher is not available, you can watch the self-learn videos. After that, we have self-learn flashcards also. If you want to revise a particular topic in very less time, you can just go and watch this flashcards, and this will be nothing but a quick revision for you. After that, we have adaptive practice, and we have Rank Assurance program daily test, RAPDT daily test for you under this program, and we have Rank Assurance program test series also. So for that, if you have any doubt, you can always use our doubts app for resolving your doubts. And if you want to join Rank Assurance program, just click on this link. It is given in the description box. Click on this link, register yourself, and you can join this Rank Assurance program by just going here, right? So I'm hoping to see you guys in RAP program also. If you want to know about the daily class schedule, if you want to get notes and assignments of this daily sessions, join our Infinity Learn Telegram channel. Description is given, link is given in the description box, right? So go there and join the Infinity Learn Telegram channel. Fatafat se, guys. And if you like this video, then hit on this like button, share this video with your friend, and subscribe to our channel by pressing bell icon, right? So guys, let's crack NEET together. Okay, so करना क्या है, like, share and subscribe, और Infinity Learn channel पे बने रहना है for more updates. So that is it for today's session, guys. Thank you so much, everyone. I'll see you again on Thursday with PYQs of collision and center of mass. Take care, everyone. Bye bye, guys.